Who controls our data? Big corporations or us? Could decentralization be the key to freedom from censorship? I'm your host, Alex Kehaya, and this is The Index. And today we're answering these questions with Dmitry Ryajov, founder of Codex. We will dive into how Codex is building a censorship-resistant, decentralized storage layer that is redefining the Web3 stack and how we protect the world's most valuable information. Dmitry, thanks so much for being here.
Thanks for having me.
So, yeah, tell me your story. I'm really curious, why you're building this and kind of how you got to here.
Yeah, absolutely. So, I guess I started back in maybe 1997, kind of started dabbling with computers, and then, went on from there. I eventually got very bored of my, day job and just working on kind of traditional software. I worked for a number of different companies in the past, and I was doing some soul searching and kind of trying to understand what else is out there, and I stumbled upon Ethereum and IPFS and libp2p and stuff like that, and I've always wanted to contribute to open source, and I kind of said, all right, this is my chance. This is it. I kind of have to do something a little different, and I started digging into the technologies, and I eventually became, very involved with the libp2p and IPFS projects. I contributed some pieces to that. I was one of the main maintainers of the JavaScript implementation for well over a year, and that's what got me into peer-to-peer decentralization and open source. That was my first foray into that. Yeah.
Very cool. And what attracted you to crypto? How long have you been in the space?
Yeah, so around 2016 and 2017, that's when I kind of started paying attention to it. When Bitcoin initially came out, I kind of ignored it. It didn't click any buttons, and I didn't pay too much attention to it for a while until I kind of stumbled on Ethereum and again IPFS and libp2p, which were kind of like my two large interests back then. And what drew me to it was the tech. I was nerd sniped, I guess, and I just kind of I was fascinated by the approach, by the premise of what Ethereum was doing, which was kind of like the world computer. I think that's one of those conversations that is happening right now, and what's the North Star? What are we building? Back then, for me, that was a very attractive sort of thing that Ethereum was trying to achieve, which is being the world computer, and that's what attracted me to it, definitely. Yeah.
Yeah, I mean, we got into the space actually around the same time. I saw the Bitcoin white paper very early, maybe 2010, and then I was like, wow, this is really interesting. And I kind of got it right away, but I just was I was in my early 20s, and I was kind of just forgot about it, Yeah. And then later on, back in a few years later, maybe 2013, I almost bought some and then didn't, because I was like, oh, it's so risky. It feels so risky, And I was a teacher. I was a high school, middle school teacher back then, making no money at all. And it was just felt so risky to even put a couple $100 in was a lot for me back then. But then I became an entrepreneur around the same time. And in 2016, my business partner, Brian, started a company called Orchid. It was a decentralized VPN project. And I joined them at the end of 2016 and led BD there for 3.5 years. So yeah, very similar time frame, very similar reasons for getting into the space. Why don't you talk a little bit more about I think decentralized storage is super interesting. There's been obviously Filecoin, Arweave. There's Shadow Network. I don't know if you've seen Shadow on Solana, but that's been one that's kind of about to launch. They've been working on that for a couple of years. Can you just talk about the landscape a little bit and what it is, what it kind of enables for people, and maybe why they should care?
Yeah, absolutely. So, I mean, there's there's quite a few projects like the ones that you mentioned. Definitely, there's a lot of similarities, but also quite a few differences in how each of them approaches decentralized storage. It's actually funny because it is people understand. Storage is understood differently by different people depending on who you ask. Like, people might say that BitTorrent is a storage protocol, or IPFS. It's commonly mentioned as part of that group, and none of those, neither of those two are storage protocols.
Really?
Yeah, I mean, you could think of them as content distribution or file distribution systems, but they're definitely not storage. Yeah, and that's a very kind
is
of
IPFS storage and Filecoin is not, or are those two separate? I mean, I thought those were like the same thing.
Well, so Filecoin is the storage layer for IPFS. That's how it was positioned, and that's how it was. That's how it came about. The two are, doing these two things is actually relatively they're different things. Storing data versus distributing data. Those are two different things. So, but.
No, that makes sense to me. Like, a lot of people might not fully understand that about like the physical infrastructure of the internet, because that's what it goes back down to is actually the physical infrastructure. The internet is powered by hardware, and that hardware it is connected by fiber in the ground and moves at the speed of light. And if you're going to store things, that's one thing. You send it to a database, which is a hard drive. But then how do you get that to the users, right? And if you store it in a hard drive in Texas in a data center, it also needs to persist that same data all over the world. In order for it to be usable, because if you're on the other side of the planet and you want it, it moves at the speed of light, but it still has to travel through all this networking, and you kind of get into like complicated stuff about networking and why that is slow, but it can create like a really bad user experience. And so this is like the big challenge with decentralized storage, right? Like centralized storage is AWS S3 buckets, and you can just literally click buttons and you have nodes all over the world, close to users, and it's a good user experience. And that's not how this, like, designing an economy that like balances that out, the distribution of the data, and stores it, and storage and distribution are two different parts, right? It's kind of hard to explain, but I'm hoping I'm articulating it well for people who might not know.
No, I mean, I think you're making a great point. Yeah, absolutely. I mean, storage and distribution are definitely very different, and we've actually had quite a few distribution protocols in the past. Like, you can think of Napster. I mean, of course, BitTorrent, Kehaya. You can go on, right? Like,
and let me look. PTP, right, is a distribution network, right? And that's the distribution protocol. It's not a network, but it's a protocol, right?
PTP is a stack for building peer-to-peer applications. So you can build your own. It's like a framework or an SDK. It's a stack for building, peer-to-peer applications. It gives you sort of like the framework and then you can choose the different pieces and how do you want them to, like, different transport protocols, you can implement your own protocols on top of that. So this type of we've had a lot of this type of software which just kind of moves bytes around in a network, right? Peer-to-peer networks, etc. And those have been quite successful, I think, if you look back into like the mid 2000s or the beginning, the early 2000s, I'd say. I think it accounted for something like 40% of the internet traffic at some point. It's a huge number. So content distribution or file distribution protocols have been around, and they have to be, they have shown to be successful. But the storage part is, I think, where we haven't necessarily been as successful as that. So, like, how do you make this decentralized storage networks? Decentralized data distribution networks. How do you also add some sort of persistence to these types of systems? Yeah, which is
what Codex solves. So, how do you guys solve that problem?
So I would make a claim that persistence or durability in decentralized networks is a fundamental problem. So we
100% agree. 100% agree. I mean, we built a product on IPF. They used IPFS and Arweave, and there were challenges with both of them. But one of the things with IPFS is you have to pay to pin data in a location, and if you stop paying, it's not there anymore. And so, like, the value prop of decentralized data storage is it's always there. It's like the blockchain, right? It's like immutably there, and there's an economic problem to solve to make that happen. And so that's where the persistence and durability comes in that you're talking about, right?
Yeah,
like,
absolutely.
You know, and so how do you deal with that?
Yeah. So a big portion of our effort went into understanding what persistence and durability is in these types of networks, and how do you get there, right? And the way we solved it is, well, first of all, we try to kind of at least attempt to formalize this. I think one of the problems in decentralized storage is that even though there has been a lot of interest in it, a lot of the problems aren't necessarily well formalized or well understood. And one of the things we try to do with this is we kind of try to formalize what durability in the centralized network means and how do you get it. And what we did was, to make the story short, we created this conceptual framework called the Decentralized Durability Engine, which kind of gives you some mechanisms that your protocol has to implement or have in some form in order to be durable. And there's a slew of mechanisms. There's 5 mechanisms that you need, which is redundancy, repair, dispersal, incentives, and I might be forgetting one, and auditing, remote auditing, what we call. So, like,
verifying it's still there and it's correct.
Exactly. So data needs to be stored redundantly. It needs to be repaired if there are failures. You need to detect these failures, which is the auditing mechanism. You need to incentivize, penalize bad behavior, incentivize good behavior, and you also need to place data in such a way that failures are not are uncorrelated. So, like, if you make a bunch of copies but you store them all on the same hard drive, it's not very useful. If your hard drive blows up, then all your copies are gone. So that kind of thing. Yeah. That's how we approached durability. Yeah.
Right. And so how far along are you guys in actually implementing this and seeing it work? Because, like, obviously there's a lot under the hood there, right? These are the basic themes of problems you need to solve for. But, I've seen teams sit around a whiteboard for like years to deal with some of this stuff and, like, try to build a system that works. So where are you in the process?
I think we're probably about close to 90% complete with a lot of these things. We're actually entering the point where we're focusing on reliability, performance, scaling, etc. We've been able to work through most of the fundamental problems, like how do you deal with redundancy, how do you deal with remote auditing, what kind of proven system. We're using ZK snarks and we're using erasure coding for redundancy and things like that. So I think all of right now we have worked through most of these major problems, and we're at the point where we've either implemented most of it or in the process of, and also in the process of debugging, bug fixing, and stabilizing the software. Yeah.
Okay. Cool. And so it's not, is there like a test net or something people can go and like developers can use?
Yeah, absolutely. We have a test net. If you go to docs.codex.storage, there's a quick start guide and a whole bunch of resources for you to get started with the test net.
I know one of the challenges we ran into when I was building Olaplex, which is like this NFT platform. We were storing NFTs on IPFS and on Arweave. It's just like we were having to maintain for our own full node on Filecoin, right, to an IPFS to like our own gateway, right? And that was, I know there's a team called Saphira that kind of tries to solve that problem, and it's like a layer 2 on top of IPFS and Filecoin. And like generally speaking, in the data layer of crypto, because you have read and write is kind of like the big thing, and then and then there's that's reading from the blockchain, but there's also just like generalized data storage, right? Of like what would normally go in an S3 bucket on AWS. Engineers who are building apps just want it to work like S3, like it should just be as easy. And that I have found has been a really big challenge for projects that have tried to go to market in this space. And so how are you making that work? Yeah,
it's definitely, I totally understand that is where we all want to get to. The problem is that there are some pretty big prerequisites to sort of, or pretty big hurdles before we actually are able to provide that level of usability. And this is related to a whole slew of issues like performance, how do you actually make this update efficiently? There are limitations related to the, I guess you guys are working with Solana, and Solana definitely has, it's more performant, even though it makes other sacrifices. And that allows you to build a relatively different system that has potentially better performance characteristics, but also has to sacrifice some security properties, etc. So the bottom line here is that there are some fundamental issues that we still need to work through, and precisely this is what we want to focus on going forward after we launch our testnet, our mainnet. Our work is going to be focused on scaling and usability mainly because, yes, those are definitely very important, and that's what developers are looking for, and that's what.
So maybe talk about like okay, here's what a developer really wants. That's the value prop they want to get out of a storage system. And then tell me, where does your system need to improve? And it's not just your system. All these systems have the same problem.
Absolutely.
And so I'm that's why I'm like really interested in what your ideas are on the usability side. If you're able to talk about stuff that you guys kind of got in the pipe. So like, what's the normal, this is how it should work, and then this is how it actually works in a decentralized system, and potential ways we solve for that.
Yeah, so let me just start by saying that I think the very first thing a storage system needs to do is to store your data reliably, right? So we need to figure that part out first before we can actually move on to working on any of the other pieces. Yeah. So like that's what we focused on for this iteration. And in fact, it's been a little over 3 years that we've been working on this particular problem. In terms of where, and I think we've achieved a very good understanding of what the problem is and how to address it. And, I think that's right now it's our strongest value proposition, that we can actually guarantee you that we're building a system that has this particular durability properties, and that it will not lose your data under this conditions, right? So I think that's kind of like the core, the most important part of a storage system. If it doesn't store data, then it's probably not a storage system. Okay, so with that out of the way, we're definitely. Well,
before we move on, I just want to point out for everybody listening, like, it sounds kind of silly to say that, but it's not. The implementation of these things are a lot harder and more complex, especially across a distributed network of individual actors who could do all sorts of things to kind of game that system to earn money and like pretend they're storing it. Because the thing that people don't understand is that like it goes back to physical infrastructure. There's a hard drive somewhere that someone paid for that is storing that data, and when it fills up and they want to participate in the economy, they have to get more. It's just like real estate, right? Like it's rented out, it's fully allocated, and it's there until it makes more room. And the only way to make more room is to delete shit off of it. And so this is like one of the examples of like where things might fall apart right? In a system that has a bunch of that's permissionless with a bunch of independent actors. So I just want to I just want to make sure people understand it's like not that simple, as sending data from me to your hard drive. It's not that simple. It's way more complicated.
Absolutely. I mean, even centralized systems, like if you start looking behind behind what's AWS or S3 does, and any of this large Dropbox or whatever, if you start looking at their architecture, you very quickly realize that it's not just like throwing it in a hard drive and forget about it. There's a whole system behind this which is incredibly complex, and they have it. Should I say it's easier in a centralized setting to handle this sort of flow and provide this sort of guarantees. In a decentralized setting, the claim is that we haven't really figured that out until recently, and like another claim that we're making is that we the reason why we wanted to spend so much time kind of understanding this problem is that we wanted to get it right, and we wanted to have actual proof that we're building the system in a durable way. So if you start looking at a lot of these projects out there, you will quickly realize that there's a bunch of mechanisms and systems that they're kind of combining and trying to use, but it's very hard to tell whether these mechanisms are actually doing anything at all, or they're going to lead to any sort of durability or the durability that they're claiming that it will provide you. So yes, I think it's so just to provide a little bit more color to what you said in terms of why durability is so important and why you that's the first thing you want to figure out before you move on to anything else, because otherwise you'll end up building a system that you can't really say for sure whether it's going to store data or not, or it's going to fall apart under this particular conditions.
Yep. Yeah. Okay. So next thing. Well, you were just starting on it when I double tapped on this, but you were about to say what like the next issue is.
Yeah, the next issues would be mostly around performance and usability. So once you get this large piece of the puzzle out of the way, you can actually start focusing on solving for this usability issues, right? So one of the things that I'm very looking forward to is dynamic data. So the ability of providing writes and updates to an existing data set. Right now, that's not possible, and it's not possible for many of the systems, not just Codex. And I haven't actually seen any system that's been able to do this in a way that is actually works.
Can we break that down just a little bit? So writes and updates, it's you're writing data means you're sending data to the database and it's getting written in there and stored, however the architecture is. And then updates is like you go back and find that same piece of data. Like you find my name and instead of spelling it ALEX, you spell it ALEKS or something. And you update that same record. I think the way other systems works today that are like on the market is they don't update actually. They create a new record. Right? Because they don't have the ability to really update for whatever reason. And users don't really understand the difference, but it's kind of an important distinction. And the crazy thing is you got to update it across the whole network, not just one place. It's got to be updated with every location that piece of data is stored. And this, again, I keep going back to the physical. Like people don't, it took me the longest time to realize this, that the internet is actually like physical infrastructure. I know it sounds really dumb when you say it that way, but it's true. It's physical infrastructure, and everything you see on the internet is stored in many locations. That's the only way it actually gets to you in an efficient fashion. How do you, so you're working on this, you're working on the update, the write, the usability from that, the way you interact with data once it's stored. And then how, like, what does that look like? What are the solutions like shaping up to be?
Yeah, so the challenges there are essentially how do you efficiently commit to this data? So what happens is, depending on how you're dealing with your data, but what's available to you, the current set of tools that are available to you, the cryptographic primitives and all of that, they're all very costly. And so you got to be careful that if you have a very large amount of data, every time you make a change to that, you might have to recommit to the entire data, right? So like that's the first thing you have to think about avoiding. It's incurring this penalty of having to recommit to the entire data, even if you just changed one byte, right? So there's a lot of nuance there in general. What sort of cryptographic primitives you have available, how to use them, how to put them together, so that you can amortize the or reduce the amount of changes or recommit into the entirety of the data every time a change is made, right? So that is where a lot of this complexity is right now. Essentially understanding how do you amortize these updates, because really from a high level it's not that complicated. You could either do an update or you could do an append-only kind of approach to dynamic data. Both work, but they both have their own set of drawbacks, and the penalty for that they incur in might be not, and the cost associated to those updates, it's right now not. If you do it naively, it's not going to work. That's basically the point. So it's all
because the software, the machine, the hardware that's doing the update, right? Like it's doing something. It's costing it. It's a resource that it needs to get compensated for, right? The action of updating is a resource that needs to be, paid for.
Yeah, that and then the time as well, right? So if you do this naively, you might end up having to spend literally days having to recommit to every single change you make could potentially lead to days of required recomputation of the data, which is obviously not very practical, right? So what you want to do is to reduce that amount of time, reduce the amount of resources that's required, such that it becomes practical. Yeah.
So where is Codex in the development process? Sounds like you're going to do mainnet soon. Like what kind of traction do you have? Have you guys raised money, that kind of thing? Can you walk me through where the company's at?
Yeah, absolutely. So we're part of the Logos Collective, and we're being funded by the Logos Collective.
What's that?
The Logos Collective is, there's a political aspect to that. There's a manifesto online. I think if you go to logos.co, you can read all about that. But it's also a set of projects, and currently it's 3 projects called Waku for messaging, Nomos for secure private computation, it's a blockchain, and Codex for storing data. So that's how we're getting funded right now. We are also going to...
Are they like grants or investment, or is it...
They're investments. Right? Yeah. They're investments. There's a structure called the IFT, which sort of oversees progress and makes decisions on whether we continue funding this project or not. But the IFT is very aligned on sort of building this decentralized stack. And this decentralized stack, in our understanding, needs to have messaging or secure spam-resistant messaging, which is Waku again. It needs to have a storage layer, which is Codex, and it needs to have computation, right? Secure private computation, which is Nomos. And this is kind of our take on the what used to be known as the Ethereum. I forgot not the trilemma, the Trinity, the Ethereum Trinity. The Ethereum Trinity, where we had, you can probably edit that out. Sorry,
That's okay. All good.
So the Ethereum Trinity, which included all of this sort of pieces. So like the point is that if you really want to build truly decentralized applications, you will need all of these 3 components, right? You need computation, and you need messaging, and you need storage. Essentially, that's sort of like the main idea behind it. And what we're trying to achieve is we're trying to build this decentralized technology stack to build truly decentralized applications.
Yeah, and so they're like separate entities and stuff, but you're like the CEO of this one.
Yes.
Did they recruit you? Like, how did you end up working on this? Like, did they recruit you and you joined, or did you guys kind of co-found it together, or what's the background there? I'm just curious.
I think we kind of we co-founded this together, I would say. So what ended up happening was that I was working on a different project called Mustakala, and prior to that I worked on libp2p, and so Status was working on this Ethereum client called Nimbus, a beacon client or a consensus client called Nimbus, and they needed a libp2p implementation, and so they reached out to me essentially to help them build an implementation of libp2p in a language called Neem. I'm not sure if you guys are familiar with that, but there's it's what Nimbus is written on, and it's one of the existing clients for Ethereum beacon chain. And in the process, we also started the conversation of building a decentralized storage protocol. So I kind of joined to build libp2p and also to work on this decentralized storage protocol, but that happened a little later after we wrapped up the libp2p.
Yeah, I'm always interested in how these things get started, because I just did a quick, like while you were talking, look around at Logos, and it's kind of a venture studio model, it seems like. Yeah. And I'll have to read up on the people involved, but it seems pretty cool. A couple different projects, and it makes sense to kind of loop all that together as like one stack of technology. And this kind of goes to show you where we are in the space still, right? Like, you've got entire teams building the full stack of things that like are needed to implement like products at the end of the day. Yeah. To make them work. There's lots of different ways of approaching it. So we're getting towards the top of the show here, and I always ask the same thing. But like, what have I not asked you that I should have asked, or that you wanted to talk about?
Oh, that's great. Actually, I think we covered most of it. I was looking forward to talking about like durability, and I think we went into that. Maybe we could talk about spam resistance and anonymity and privacy.
Yeah, privacy was a big question I actually had earlier. I had forgotten, so thanks for bringing it up, because that's another huge challenge, is like, how do you preserve privacy of data? It's one thing to ensure that I own my data in a decentralized system. It's another thing to make sure it's protected from the data storage or the person who's storing it. That's a terrible word. It's not storager. We should cut that. But you know what I mean? Whoever's storing the data, like, I don't want them seeing all my data, So how do you deal with that?
Yeah. So for preventing someone peeking into your data, I mean, there's encryption, right? Different encryption techniques that are incredibly effective and very secure. So we can all trust encryption. Otherwise, we wouldn't be building blockchains and doing any of this stuff. None of it would work. So encryption is definitely the answer there. In general, like, what kind of encryption? It all depends on the particular needs. Right now, we're definitely trying to look into more advanced encryption schemes, but the first iteration is just going to have a regular symmetric key encryption. We haven't yet decided on which particular algorithm we're going to be using, but the way that this is going to work essentially is that for private data, you would only publish the encrypted data set, right? And that way, no one but you can actually retrieve it and then inspect it. For public data, the data is also going to be encrypted by default, but the public key is going to be published as a separate CID. We use content identifiers, and the public the key is going to be published as a separate identifier. So you could as a storage provider, you won't be able to, unless you know what the identifier that contains the key is. You wouldn't be able to know what you're storing. There's also another point is that no storage provider is storing the entirety of the data set. They're only going to be storing portions of it. So it's going to be an encrypted data set, and then it's going to be split into what we call slots and distributed across a number of nodes in the network. And none of the nodes is going to hold the entirety of the data. So there's several layers of protection there in terms of I, as a storage provider, for example, I'm not necessarily accountable for, or I have reasonable or plausible deniability, because I don't know what I'm storing exactly. And you as a user is also protected, because if you don't want to publish the private key, if your data is completely private and it's only meant for you and whoever owns the key, then you just don't publish the decryption key. Yeah.
Makes sense. All right, last question. I know I said that was the last one, but I actually have one more. I was at a kid's party yesterday, and a friend of mine who is not in the tech space or crypto at all asked me, because I get asked what I do a lot of times, and then people, a lot of my friends are like, I don't know what he does, and she asked me, what are the bullet point benefits of blockchain technology? Because I was explaining to her what it is, and what would you say are your top 3 or whatever bullet points of the benefits of blockchain that you would explain to somebody not from our space? How would you answer that question?
I think, to me, the major benefit is definitely decentralization, right? It's not just a buzzword. It's not just a random property. I think this is actually a fundamental property that we kind of came across or invented or discovered, whatever you want to call it, with Bitcoin and prior attempts as well, obviously. But where it really actually materialized and we kind of made a huge breakthrough was with Bitcoin. So to me, the reason why decentralization is important, it's because, well, first of all, it's something that we didn't have access to. We didn't have this ability in the past where we could do things in a disintermediated way. And what that means is that, well, there are no intermediaries in the process, right? So we can do all sorts of things, including financial transactions, money and stuff like that, but obviously many other things as well that in the past required trusted intermediaries and created a huge amount of problems. Corruption is one side effect of intermediaries, right? So we, I think, have stumbled across a primitive that didn't exist in the past, and we're just figuring out how to use it the best, right? And I think some of these use cases are very, very clear. Again, removing intermediaries reduces costs, removes all sorts of potential abuses and et cetera from any sort of transaction or interaction. But then there's probably many other things. So to me, decentralization is actually a thing in and out of itself, a primitive and a goal that it's very important. Now, how do we make the rest of the world realize that? I don't think it's going to be a quick thing, and I don't think it's going to be a quick something that happens overnight, but I think more and more people are realizing and understanding the importance of that.
Well, I think I hope that my show can help with that process, educating people. But when I answered her question, I brought up self-custody and disintermediation as 2 of the big value props. And I always explain it in the context of other countries like Venezuela or somewhere where you see, I didn't even get into the hyperinflation piece. That's a whole nother value prop of Bitcoin. But, just the ability to transact without the government in between and all the bureaucracy that comes along with that. We take that for granted in the U.S. because a lot of people haven't experienced being debanked or having their money just taken from them or their entire banking system just like shutting down overnight, right? Or a run on the bank, right? Which is ironically what happened with FTX, right? Because it was a centralized system where people gave up control of in custody of their asset. And so I always try to explain it in that context, like, hey, imagine you live in this kind of place where this happens regularly. And crypto, ironically, people in crypto experience it pretty regularly in the U.S. over the last 4 years, 5 years, 10 years from getting debanked just for working in the space. So hopefully that's going to change. But that's one like I run my entire business, both this podcast and my company ABK Labs. Is we keep barely enough cash in the bank to cover payroll every 2 weeks. Wow. Everything else is on multi-sigs and hardware wallets. And finally, we're at a place where, at least on Solana, like I use squads pretty religiously, and we have a couple different off-ramp providers that they integrate with. I can actually run the business that way. The accounting's a little bit of a pain, but we kind of deal with that. We got people who we pay to help us with that. But yeah, that was like the dream, and it wasn't really possible until about a year ago, I think. Well, look, I appreciate you coming to the show. Thanks so much for sharing your story, and we wish you the best of luck. Thanks for being here.
Thanks so much. It was a pleasure. Thanks for having me.